Hello everyone. In this video, I'm going to talk about one of my favourite subjects. This year, I took part in the Junior Mathematical Olympiad, a maths challenge held every year by the United Kingdom Mathematical Trust. There are lots of interesting and challenging questions in this paper, the hardest of which were the Section B questions, which many mathematicians look forward to solving. For this video, I picked 3 of my favourite questions to explain to you. Here we go. So this is question B5 from the Junior Mathematical Olympiad paper of 2021. Question B5 states, in Sally's sequence, every term after the second is equal to the sum of the previous 2 terms. Also, every term is a positive integer. Her 8th term is 400. Find the minimum value of the 3rd term in Sally's sequence. To start solving this question, let's write out Sally's sequence using variables. Let's make the first term A and the second term B. This means that her 3rd term will be A plus B, her 4th term will be A plus 2B, her 5th term will be 2A plus 3B, her 6th term will be 3A plus 5B, her 7th term will be 5A plus 8B, and her 8th term will be 8A plus 13B. Now we know from the question that Sally's 8th term is 400. This means that 8A plus 13B equals 400. Now we know that both 400 and 8A are divisible by 8. This means that 13B must also be divisible by 8. However, 13 and 8 are coprime. This means that they don't share any other factors apart from 1. Therefore, B must be divisible by 8, or must be a multiple of 8. Now, it's also important to note that the value of B must be less than 400 divided by 13. 400 divided by 13 equals to around 30.7, which is approximately 31, and hence B must be less than 31. Now this means that there are 3 values of B. These values are 8, 16, and 24. Now if we draw a table with the value of A in the first column, the value of B in the second column, and the value of A plus B, Sally's 3rd term, which we want to find, in the 3rd column. Now if we substitute each value of B into this equation, 8A plus 13B equals 400, we get the following values of A. When B is equal to 8, A equals 37. When B equals 16, A equals to 24. And when B equals 24, A is equal to 11. This gives the corresponding values of A plus B. 37 plus 8 is 45. 24 plus 16 is 40. 11 plus 24 is 35. Out of all these values, 35 is the smallest. This means that the minimum value for the 3rd term in Sally's sequence is 35. So this is question A10 from the Junior Mathematical Olympiad paper of 2021. Question A10 says, Amy, Bruce, Chris, Donna, and Eve had a race. When asked in which order they finished, they all answered with a true and a false statement as follows. Amy: Bruce came second and I finished in third place. Bruce: I came second and Eve was fourth. Chris: I won and Donna came second. Donna: I was third and Chris came last. Eve: I came fourth and Amy won. In which order did the participants finish? In order to solve this question, we need to use a table, as shown here, where the first column has each of the names, Amy, Bruce, Chris, Donna, and Eve, and the second and third column are for the first statement and the second statement. Now if we have a look at the statements, we see that Amy and Bruce's first statements both match. So let's assume that they're both true and put a tick in both Amy's first column and Bruce's first column. This means that we know Bruce came second. This means that Amy must not have finished third and Eve cannot have finished fourth. Now this contradicts Eve's statement because Eve said that she came fourth. This means that Eve's first statement is false, and hence Eve's second statement must be true, and therefore Amy came first. Now, if Amy came first, that means that Chris's first statement, saying he won, must be false. But his second statement says Donna came second. But we know from Amy and Bruce's first and second statement that Bruce must have come second, so both of Chris's statements are false. This means that Amy and Bruce's first statements must also be false, as if they are true, Chris has two false statements, rather than one true and one false. So let's make a new table. Write the names of the people, Amy, Bruce, Chris, Donna, and Eve. Now we know that Amy's first statement is false, and Bruce's first statement is false. This means that Amy must have come third, and Eve must have come fourth. And if Eve came fourth, this means that her first statement must be true. And we know from the fact that Amy came third, that Eve's second statement must be false. Now since we know that Amy came third, this means that Donna's first statement must be false, and hence her second statement must be true in saying that Chris came last. This means that Chris's first statement is false. This means that his second statement must be true, and hence Donna came second. Now we have the people in the positions of second, third, fourth, and fifth. This just leaves out the person in first place, and as Bruce is the only person not mentioned already, Bruce must have come first, and hence the final order is Bruce, Donna, Amy, Eve, and then Chris. This is question B6 from the Junior Mathematical Olympiad paper of 2021. Question B6 reads, the integers 1 to 4 are positioned in a 6 by 6 square grid as shown and cannot be moved. The integers 5 to 36 are now placed in the 32 empty squares. Prove that no matter how this is done, the integers in some pair of adjacent squares, i.e. squares sharing an edge, must differ by at least 16. Now in order to have the numbers 1 to 4 next to a number from which they differ by at least 16, we must put in the squares adjacent to each of them the next smallest number, i.e. 5 upwards. So let's do that now. But now we reach a problem. In this final square, we must put in the number 20. However, 20 minus 4 is equal to 16, which means that the difference is not going to differ by at least 16. And what's more is that in this square, the only number that can be put in this square must be greater than or equal to 20, as all the other numbers are already positioned as shown in the diagram. Now we can't swap 20 with another number, as 20 minus 3 is 17, 20 minus 2 is 18, and 20 minus 1 is 19. This means that no matter how the grid is filled, the integers in some pair of adjacent squares must differ by at least 16. I hope you enjoyed this video. Hopefully I'll be back for more. Thank you for listening.